Good morning, everyone. Welcome to the Computer Literacy Seminar series put on as a joint venture between IT and the Center for Data Science. My name is Caitlin Motes, and I'm the IT project manager here on campus and kind of rallying our fantastic students around. With us today, we have Nadine and Jasleen, who are our two students who helped put everything together, but also Professor Charles Bryan, who teaches in our CS department. So he's going to be talking to you today about the introduction of web development principles. And go ahead and take it away, Charles.
Sounds great. So thanks for the introduction, Caitlin. Again, my name is Charles. For today, you can just call me Charles. If you have any questions at any point in time, throw your hand in the air and ask. For those of you, is there anybody on Zoom? Can't tell.
It looks like there's about 5 people.
Yeah, hi, everybody there is on Zoom. If you're on Zoom, if you have questions, put your hand in the air and can somebody else be checking and watching that. You can also put it in the chat. You can type in the chat and ask a question. Any point in time, ask, please do, okay? So we're going to talk about introduction to web development principles. And when I was first approached, I gotta remember the camera's there, first approached with this topic, it was introduced as, let's create an HTML web page, let's put some CSS in it, and let's also learn some JavaScript so we can have some interactivity in that web page. And my thinking is, if this is truly to an audience of people who aren't necessarily computer literate or are trying to become computer literate, we need to have understanding of what a web page is, where does it come from, and how does it all come together before we can even start creating these web pages, okay? Because I'll be honest with you, if you want to create a web page, learning some HTML and CSS, you can go to an online tutorial for that and get the brass tacks, make something show up on the screen that's going to be in a web page. But to truly understand web development, we need to have an understanding of underneath the hood, okay? So I want to start us off, I want to do some interactivity here. I want feedback from you and you on Zoom. So here's my first question. What was the first web page that you looked at today? Keep it clean, okay? What's the first web page? And I can start us off, and this is somewhat embarrassing. I looked at Twitter. I go through my Twitter feed. That's kind of my primary source of breaking news. And then if I see something that's interesting, I will then go to a news organization like AP. Or I saw last night, I saw this morning that last night Bryan broke the scoring record. So that was one of the first tweets I saw. So I went to ESPN and then read the article there. And I will admit that when I looked at this web page, I had just gotten out of bed and was sitting in the bathroom. Okay. Okay. Who else? Reddit this morning. What subreddit? Just all of them. Yeah. How many minutes after your eyes had opened up in bed?
Oh, less than a minute.
Yeah. Were you even still in bed? Fantastic. Who else? Amy. Wait, why are you on Stack Overflow? The assignment was due the other day. Why are you on Stack Overflow? Fantastic. What time? So some of you might have checked the web page when I said today. You might be thinking, well, I was up at 2 a.m. That's today, right? So when you woke up this morning, was it Stack Overflow? Or was that Stack Overflow last night? Both. Fantastic. What else? Who else has been on web today? Let's look at web page. Tom. Gmail. Fantastic. Yeah.
Upstairs to my office for about 5 minutes.
Uh-huh. Yeah. You got the routine, right? And the routine means looking at a web page. How about over here? Reddit. All just the all.
No, just I guess got
Oh, okay. Okay. Michael. 491. Yeah. Oh, so okay. So your own web page. Fantastic. Understood. Okay. What? Remind me your name. Taylor. Go ahead, Taylor. You're gonna say. New York Times. Yeah. You got to click on it. How long since you woke up? Were you still in bed? Uh-huh. So the point of this is, right? And even those that didn't answer, some of the first things you did upon waking up this morning was interacting with a web page. Okay. Now let's go back in time, and some of you, just looking around, some of you probably aren't going to be able to know when was your first interaction with a web page, because some of your first interactions with a web page, you were 2, 3, 4 years old. Okay, but who can remember? Does anybody remember? Anybody old enough to remember pre-web, pre-internet? So then, what was your first interaction with the World Wide Web? Maybe not the first web page, but hey, we'll get there. Okay, Tom, do you remember? Well, we'll get there. So for me, I in the early 90s when I was in high school, we had a personal computer at home. We had a modem, and I connected to bulletin board systems, which were text-based. Part of the internet, yes, but not true World Wide Web, and these weren't web pages. Okay. When I went to college in 1996, that was my first introduction to the World Wide Web, and we were in the computer labs. And in the computer labs, I used both Internet Explorer and the PC lab, but then we had a Unix lab downstairs, and we were using, I think at that time, Netscape on the Unix. Ooh, I just heard something. I just heard something in here. Did somebody on Zoom need to talk to us? My ear talked to me. Okay. So who's young enough, though, that when you were a small child, like as a small child, you remember looking at the internet? And not gonna admit it. Yeah, my daughter's only 8. She knows nothing but the internet. Okay. Now here's another question. When was the last time you, in an entire day, did not interact with the internet or a web page?
Last time I went camping.
Yeah. Well, how long ago was that?
Probably half a year ago.
Half a year ago. Who else? Tom can't even think about it. Can't even imagine it. Amy? Fantastic. Where'd you go with Knowles? Did you go to Alaska? I love Knowles. Knowles is incredible. National Outdoor Leadership School. Fantastic. Talk to Amy about Knowles. I'm sure if she's a Knowles grad, she's going to love it. I love the fact that you went on a long Knowles trip, right? 7 days out, something like that. 3 weeks, no internet. This group over here looks a little bit younger. When was the last time you went without the internet? Last year. Good. Yeah. Yeah. The day I was born, right? You know, I woke up on my iPhone. Yeah. That for me. So I go. Oh, there's a chat. What's the chat say? Is that somebody got an experience there? 10 years ago. 10 years ago. So I don't camp, so to speak, but I go climbing. This is in the North Cascades. And we were on a climb and we were bivvied. We just dug snow holes and we're bivvied in the snow holes, and we didn't have a signal there. But you can be in some pretty extreme locations. If you go climbing in the Tetons, Wyoming, back to Wyoming, the Tetons, the Grand Teton National Park, just south of not Yosemite, Yellowstone, right? And you climb those mountains. You climb the Grand Teton. You climb Mount Bryan, okay, Middle Teton, Tiwanaku. When you get to about 8,000 feet, you come off the valley floor and you climb up about 8,000 feet. From about 8,000 feet to 13 to their summit, you got 4G LTE up there. Okay, the towers that hit Jackson, Wyoming, are across the valley. And when you get high enough in the mountains, you got 4G LTE up there. Okay, so camping is most likely, right? Or if you go out sailing in the ocean, most likely these are the last time you access these web pages, right? The last time you went without. But not necessarily. I mean, you have to get yourself pretty darn remote to find a place where you are not connecting to the internet. Okay, so great. So you're here, right, because you want to learn how to develop a web page, right? Or our website, build a web application. But let's start way back and let's tell a story so that we can understand when we are looking at a web page, this isn't a web page, but let's pretend this is a web page. When we're looking at a web page, right, what is it that we're looking at? Where is that running? How is it running? Okay. Now I'm a son of a historian, so I got to tell history. Okay, we got to learn some history, and I like computer history. I think computer history is fascinating. So let's take our steps back to the quote unquote beginning. Now, in talking about this short history lesson, I do want you to know I'm talking in generalities here. Okay, there's some very, very generic generalities. And I'm going to start with, in the beginning, right, there was the ENIAC. No, the ENIAC in of itself wasn't the first computer, but it was the first classification, or the first computer which can be classified as similar to what we are sitting in front of us. Okay, it didn't have all of the capabilities that our computers have now, but we could think we had the ENIAC. Now, it's hard to think about it like this, but when the ENIAC computer, and by the way, I had notes, off the top of my head, I can't even, the ENIAC stands for the electronic, do you know what ENIAC stands for, Tom? Yeah, electronic, numerical, integrator, and computer, okay? 1945 when this first thing kicked off, and it was the first programmable, so for my CS students, and also IT students that want to do programming, the first programmable computer. Computers up to that point weren't general purpose in that you could tell it to do something, it would calculate it, but that's all that computer could do, calculate, right? Once we have the ENIAC, we can send it in a program and have it do that program. So the first electronic programmer, general purpose digital computer, 1945. This computer, this ENIAC, is gigantic, bigger than this room, had its human operators, but it was lonely. This little computer here is lonely, big computer, I should say, sits by himself. After the ENIAC, more general purpose computers started coming, the Manchester Mark I. It's got the, in its prototype, have the, the thing that makes them special, I guess that's what I'm trying to look for, the word I'm trying to find is they could store a computer program. With the ENIAC, you could feed it in a computer program, it would run that computer program, it could be a general purpose program, but if you wanted to run the program again, you had to feed the program back to the computer. Whereas the Mark I, the Manchester Mark I could store the program. But these computers were lonely. They were by themselves. They had the computer operators, but they didn't have their own kind. Okay. Imagine you're sitting in a room by yourself, and ants are talking to you, but that's it. These computers are lonely. Through the 40s and 50s, more and more computers came into play, these giant computers, but they were by themselves. Now, early 60s, there is a government agency called ARPA, the Advanced Research. Yeah, this is where I need to have my notes. The Advanced Research Projects Agency. This is a government agency that's sole purpose is to look at new technologies and figure out how the United States can use these new technologies. ARPA later becomes DARPA. We put a D in front of it, which stands for defense. Yeah, so, the defense is like, oh, we need these technologies. So in around 1961, researchers at ARPA came up with the idea, just the idea, okay, and started sketching out the idea of taking these computers and attaching them together so that the computers could talk to each other. Therefore, coming up with the idea of what was called ARPANET, the ARPA network, okay? Didn't exist in 1961. Computers had no network connectivity in 1961, the idea. Around mid-60s, 1965, researchers at ARPANET started the implementation of both the modeling and getting ready to make ARPANET a reality. Let's take some computers and actually connect them. Okay, wasn't until 1969, okay, and I don't know, I'd have to look at the dates, but it might not even been before we put a man on the moon, before we put a human on the moon, okay, was the first time that ARPANET actually came into play. It actually was put together with all the connections, and the first message was sent from Stanford, I think. You know that one, Tom? Stanford and I think UC Berkeley. October 29th, 1969, that was after the moon landing, right? The moon landing was earlier in 69 than October 29th at 10 p.m. UCLA and SRI, I think SRI is Stanford Research Institute. First computer message went across the network. That's not that long ago, right? I wasn't born yet, but maybe, you know, my mom and dad were graduating from college. So we had our first network signal. Okay. Moving and fast forward in time, 1970s, early 1970s, 71, I think it was, the first email was sent. First electronic mail, it wasn't called email, you know, electronic mail. Email was set up. Later in the 70s, TCP IP comes around. Who here, tell me what the P stands for in TCP or IP? What's the P? Protocol. Fantastic. We're going to come back to protocol. Okay. I'm going to give you an idea of what a protocol is, but I'm going to give you an analogy that we can think about it as opposed to like a computer science definition. Big deal for TCP IP coming around. Other networks were coming into play. ARPANET was fully functional by the mid 70s, had maybe 100 different nodes. When I say a node on a network, a computer network, that might be a computer. In a modern network, a node might be your phone, a computer, a small device, which is on the network connecting, just gaining information. A printer could be a node on the network. The vending machines out there, those are nodes on the network. By the mid 70s, the ARPANET was up with maybe 100 nodes, but other networks were coming into play, okay? In the 1980s, this is when we can first say the internet as we know it today came into play, okay? ARPANET, yes, was probably the furthest back ancestor of the internet, but by the mid 1980s, early to mid 1980s, that's when the modern internet really came into play. The thing that made it the modern internet was ARPANET and most of the other networks switched over from their different protocols, their different ways of communicating with each other to TCP IP. And so before this switch, if you had different networks, one computer could talk to another computer on that network because they used the same communication, the same language, the same protocol. But on a different network, that different network might have used a different communication, a different language, a different protocol. So those computers couldn't talk across networks. By 1983, ARPANET and many of the other minor networks or major networks, I should say, that were created in the 70s had switched over to TCP and they were all talking to each other. They're all interconnected, okay? We also got DNS. Before that, when we would address a computer, we would have to use whether it was an IP address. So if you've seen IP address 192.64.100.1 or another addressing scheme, there were still numerical addressing schemes. In the mid 80s, we came up with DNS, which is domain name service, which is going to have a human readable name like Yahoo or Google instead of 321-645-728, okay? Then in the very late 80s, 89, and into the very early 90s, we had the dawn of the World Wide Web, okay? I'm gonna go to the next slide, which is gonna talk about the early World Wide Web, but who can tell me, if you know, the father of the World Wide Web, not the internet?
Tim Berners-Lee.
Yeah, Tim Berners-Lee, working at CERN, which is the European Nuclear Research Agency. So in the late 80s, Tim Berners-Lee, who was working at the European Nuclear Agency and Research Agency, got very frustrated with the current makeup of what was then the internet. The purpose back then was to allow researchers access to other research, other papers, other documents across all these other computers across, at that point, the world, okay? And Sir Tim was finding it very difficult to find the information, the data, the research, the papers that he was looking for. And so he decided to come up with an idea of formalizing network transmissions, formalizing the way we're going to store documents, formalizing the way we're able to retrieve documents, okay? And he came up with 3 ideas, 2 of them key, one of them very helpful as well. The first 2 ideas were to use a specific markup language, he called hypertext markup language, that all documents on this, what he called web of computers, these documents would be formatted in this specific way. So that when I go to look for documents, the documents are going to be formatted in a specific way. Two, the hypertext part of this document means that we are able to link from one document to another document. Okay, and in having that link, I don't have to know about specific other research papers and search for those specific other research papers and go looking at other computers. I can have a link from one research paper to another research paper with a contextual link. Okay. The other concept that Tim Berners-Lee came up with is what's called HTTP, Hypertext Transfer Protocol. Who's seen HTTP before? Okay, modern web browsers, right? You don't really type this out anymore, but if you used a web browser in the recent enough past, or I guess the far back past, you probably, when you went to a website, Reddit, you would type HTTP, maybe S, ://www.reddit.com. Is Reddit a com or an org? Yeah, okay. We're going to come back to what HTTP is. And we're going to come back and talk about the difference between TCP/IP, which we saw here from the 70s, to HTTP and how they work together. Okay. Tim Berners-Lee also came up with the idea of a uniform resource locator. This idea is what you now commonly know as the URL, the web page, the website. Okay. Now this is going to sit on top of DNS, the domain name server that was brought into the 80s. But these three ideas was what the explosion of the web came. Okay. Along with these ideas, Sir Tim said, let's have a piece of software that, given a HTML page written in this specific markup, is going to be able to display this markup. The first web browser that Tim made was actually called World Wide Web. I don't have a picture of the World Wide Web browser. All run together using camel case for my programmers, all run together with camel case. This is an example of Mosaic, which is one of the very first web browsers that allowed what we would call, or what they would call back then, multimedia, things like images, other than just straight text. You remember using Mosaic? Yeah, okay. Coming right off of Mosaic, and I think it might even been from the same organization that made Mosaic, they made Netscape, or they made Navigator. Netscape was the company. Yeah, so early browsers, but we can see the look of the early browsers. Tim Berners-Lee's first browser they wrote, World Wide Web, not only could it only run on Unix, a Unix system, so not Microsoft or Apple or anything, it could only run on a specific version of Unix. And so the first browsers like Mosaic were able to run on different operating systems, and they became more and more popular. Other ideas that happened early in the web, original web pages, and we're going to see this in just a little bit. I don't know where my time is. Oh, I've got time. Awesome. I'm doing well on time. Was just a file. And when we look at a web page, in the end, it's just a text file. All the magic of what we see in the web page, just a file. Okay. Early web pages, other than the links, were completely static. You couldn't interact with it. You just read it. And even if it feels like when I click a link, I'm going to a new location, I feel like I'm interacting with that web page. Really not interacting with the web page itself. I'm going to a new web page. Common Gateway Interface was one of the early ways that we could add interactivity into our web pages. It allowed, and it's not actually adding them into our web pages, but it allows the user to feel like they're interacting with the web pages. With CGI, we would be able to write, say, a form on our web page. The user could interact with that form and then submit that form, and then the CGI would go process the results of the form. But the web page itself, again, was not interactive. Okay, we would submit the results off to a server, have it come back. And around this time, most of our web pages really were just individual web pages. In the early web, the idea of a website like Reddit or AP News or ESPN, where a site of interconnected web pages weren't quite the idea or the concept. Moving forward just a little bit, the web starts maturing and we start getting more and more and more functionality. HTML itself, and we're going to see this in a later slide, the purpose of HTML is to structure your text, give context to your text. Okay? The purpose of HTML is not to have red text or blinking text or make sure that text is over here on this side or make sure that your text has a specific look or feel. HTML is there just to structure your text. Cascading style sheets, or CSS, which was introduced, its purpose was to add these cascading style sheets into a given web page so that we can then style that web page. If I want text to be bold, the cascading style sheet could determine that it's bold. If I want the background to be blue, the cascading style sheets, what we're going to add in to make our background blue. So cascading style sheets weren't part of the original web. Okay, if you go into web development now, they're so ubiquitous, you might think they've been there since the beginning, but cascading style sheets weren't. Okay. Next, we started to gain interactivity in a specific web page. Not CGI, where you would submit a form and the results of the form would go to a server somewhere, process and come back, but in a specific web page. As the web became more and more popular, we wanted interactivity with a specific web page. Now, when it was decided or determined, hey, we should have interactive web pages, there were multiple pathways of research on how to bring interactivity into the web page. Where are my Java friends? Who's Java? Like, who are my Java programmers, right? Back then, it was Sun Microsystems making Java. Okay, not Oracle, but it was Sun Microsystems. And Sun said, Java, we want Java. We want to use interactivity in our web pages with Java. Their response was to come up with something called Java Applets. Do you remember Java Applets? Does anybody else remember Java Applets? A Java Applet added interactivity into a web page, wink, wink. But that Java Applet was really just a portal that sat on top of your web page and you interacted with the portal, but it didn't really interact with your web page externally. Okay. There was another technology which was similar to that, but took off and became more popular. This technology has gone by the wayside, but who's ever played Flash games? Okay. How about Tower Defense, right? TD Tower Defense, the popular Flash game, okay, right? Okay. So that was another technology that was created to add interactivity to the web pages. But in general, I'm speaking mostly in generalities throughout all of this, Flash was, again, just a container that sat on top of your web page that you interacted with. The Flash itself didn't have great functionality to interact with the HTML or CSS. The other technology that was starting to get developed was JavaScript. JavaScript's got a fascinating history. JavaScript was created as an idea from Netscape. Netscape being the company that was making Navigator, the new web browser that replaced Mosaic. And they hired a gentleman, and I don't remember his name, I don't have it written in my notes. Hired a gentleman, I think he was Scandinavian. They brought him into Netscape and said, we want you to build a language to add interactivity. And with like 8 days, he came up with JavaScript. He's like, wrote it like that. Now, the idea with JavaScript is this. Inside of a browser, we already have a form of an interpreter. What do I mean by that? When we look at HTML and we see HTML, the browser is going to interpret what that HTML is and determine how to display it. So we already have an interpreter built into the browser, which is reading quote unquote code and doing something with it. So let's build a new interpreter or build into the existing interpreter a way to look at a programming language and be able to execute that programming language at runtime inside the browser, similar to what we do with the HTML. And that idea is where we come up with JavaScript. Yes.
Why didn't they just add the job?
I wasn't in the room. Okay. I don't know. So hindsight, right? Looking backwards, there's many, why didn't they do like this? You know, they were trying lots of different things. So I can tell you that there's a lot of confusion with the name of JavaScript. JavaScript had nothing to, or should go the other way around. Sun Microsystems, the creator of and owner and manager of the programming language Java, had nothing to do with JavaScript. Okay, they were created as two different languages from two completely different organizations. The naming behind JavaScript, I don't know if this is urban legend or not, but Java was gaining popularity. And so they said, this is a popular language. Let's call this JavaScripting language. If you look at the syntax of the language of Java, and I'm sorry for attendees here that aren't, computer scientists or programming language knowledgeable, but if you look at the syntax of the two languages, there's a lot of similarity there. And I think the designer of JavaScript did that by design, but Java and JavaScript, completely separate languages, just they called one. It'd be like, let's go to this new island in the Pacific and teach everybody English, right? But actually not teach them English, but call it English because they think it is. I don't know, that analogy fell apart fast, sorry. Whatever, right? It had nothing to do with Java, okay? JavaScript gained more and more popularity to now that I saw a figure in doing research for this where something like 99% plus of interactivity with the web is written in JavaScript. Okay, so when you have interactivity in a website, it's written in JavaScript. So around this time, we started getting this idea of websites. Okay, big ones back then, AOL, and who's old enough to remember these? CDs would just show up in your mail. You would just get 3 of them in a day. Okay, and by the end of the week, if you stored them, you would have 20 of these AOL CDs. Okay. I was still getting these in college, and by my senior year, I went to a much different college than this. We all lived in the same dorm. It's called a barracks. And by senior year, my room was actually in the basement, and we had the one microwave next door. And it turns out that if you take a CD and you put it in the microwave and you put it on for like 30 seconds, you get like this really cool light show. And so we would burn AOL CDs for light shows. Don't do that at home. Okay? Don't do that at home. If you could find a CD, if you actually can find a CD that's probably a collector's item, don't put it in the microwave. Go sell it. In fact, this whole article that I'm citing here from this picture is about how these AOL CDs are collector's items. You get them, you can buy them on eBay for ridiculous prices because people want nostalgia. Amazon came out around then, okay, eBay, and then Google, yes, with an exclamation mark. Google with an exclamation mark back in the 90s and early 2000s, okay, started coming around. We also, around this time, as the web was maturing, the browser wars. Who knows about the browser wars? Here's the idea. When I write HTML, and let's say I want to define a piece of text as a paragraph, okay, I'm jumping ahead a little bit, but I'm going to use something called a tag to define that paragraph, okay? So this chunk of text is a paragraph. Me, the designer of this web page, it's not up to me to determine how the web page is displayed, how that paragraph is displayed in the browser. It's up to the browser to determine that. It's also not up to me to determine how the browser is going to read this HTML document, how it's going to interpret it, okay? And so different companies, Netscape, who was making the Netscape Navigator, and Bill Gates making Internet Explorer, and then Google coming along with Chrome and Apple with Safari, had different ideas of how to interpret the different versions of your HTML. Okay? They had different ideas of how to interpret your CSS. They had different ideas actually of how to interpret and work with your JavaScript that you added into your pages. And so the browsers wars were really which one's right, which version should we use, market share. There were lawsuits. It's kind of fascinating. Bill Gates was suing lots of people. Netscape was suing back, et cetera, et cetera. In the end, it really wasn't the companies that won out, okay? And it wasn't Bill Gates with Microsoft and Internet Explorer winning out, or Netscape, well, Netscape lost, but Google with Chrome or Apple with Safari. What it really was were web developers and a consortium coming together and say, we actually need to standardize our languages. And instead of the browser makers dictating to us what the web page should look like, and if I want my web page to look this way on this site and this site, or sorry, this browser, and this browser, I have to do different things. We need to go to the browser makers and say, your browsers need to read our HTML like this. Your browsers need to read our JavaScript like this and CSS like this. So even as early as mid 2015s, you would still have to create your web pages with multiple different cases inside of it for if a user was using a different browser. In modern web development, that is much, much alleviated because the winner of the browser wars really were the web developers saying, here are some standards. We've made these standards. This is how your browser should react with our code, not the other way around. Okay. So the web kept maturing, and around the early 2000s, 2000, 2003, 2004, what has been coined as Web 2.0 came about. And I hate this name. This name's stupid. I think it's a dumb name, but there it is. And with Web 2.0, we came, there should be spaces there. We came out with the idea of the new standardization of what's called HTML5, not quite the 5th iteration of HTML and formalization of HTML, but close enough. A formalization of JavaScript engines. So when they are in the browser, how those engines are going to interpret the JavaScript code, and then CSS3. And again, these are all about the formalizations of these different technologies. And with Web 2.0, we're going to take these technologies, put them together to build robust, interactive, and not just web pages, but web applications and web services. This whole idea also is where we start really getting this idea of what they turned back then as media rich. What we think now is just how we interact with the web. We stream everything, okay? Who's watched something on streaming within the last 24 hours? Okay, YouTube, Netflix, Disney Plus, right? It's how we interact with the web. When you went on Reddit, you went on the Reddit this morning, did you watch any videos? Oh, yeah, right? So that's, if you look now, there's also, I don't have a slide for it, but there's an idea concept of Web 3.0. I'm not going to quite get into that, but understand that we have matured. We've come a long way. Okay? Any questions up to this point? How are we feeling? Who likes a good history lesson? Or who's bored out of their minds? No? Yes, I'm trying to keep it exciting. Okay, let's talk some details. I'm going to talk in generalities with these details, okay? This is not going to be an hour-long lecture on what TCP/IP is. In fact, if you're interested, I'm sure you can go to the IT major and take an entire class on it, okay? So I'm going to talk on a couple minutes so we can get an idea of what this is. Now, first off, you've already told me protocol, okay? Protocol. I want you to think of it as just some rules for communication. You could consider or classify a spoken and written language as a protocol. Okay, let's think about written language. When I write language, what goes at the end of a sentence? No. What goes at the end of a sentence? No. Yeah, punctuation doesn't have to be a period. The sentence that I spoke, did it end with a period? No. Am I excited? And that's actually question mark and exclamation point. Yeah, right. But it's going to end with punctuation. Okay. Now the two questions that go along there, though, right? It's a punctuation. What is a sentence? Oh, okay, so that's got to be defined. If we don't have that defined, how are we supposed to communicate? Okay. How do I know the sentence ends? I've got some punctuation at the end of it. Okay. So the rules of this written language, and also with me speaking, define how I'm going to communicate with you. So let's think about computers. How is this computer going to be able to talk to this computer? If there is no rule structure, if there is no protocol, there's rules for communication, this computer can send as many zeros and ones as it wants to this computer and this computer is going to have no idea what to do with their zeros and ones. So what does a protocol do? It defines the rules of communication. Okay, so let's talk specifically about the TCP/IP protocol. When we think about the web, there are actually multiple layers of protocols that our web page sits on top of when it's coming from the server to my computer. But when we think of the internet, the primary layer of protocol that we focus on is this TCP/IP layer. And I want you to think about it like this, okay? Broad generality with an analogy in here. Imagine I've got a message and I put it in an envelope, okay? Don't worry about what's the message or how the message is written or what's the message in it, but I want to get that message to your house. Okay, I want to get that message to your house. I'm going to give it to a postman, and that postman's going to take it to your house. But there are rules that postman's got to follow, or I should say postal carrier, sorry. There's rules for that postal carrier to follow, okay? There are different routes for that postal carrier to take. The postal carrier has to know how to find your house with maybe your address, okay? And there are rules for that letter, that message I said, and put into an envelope to get to your house. Hey, the fact that it needs to be in an envelope, that needs to be part of the rule structure that gets to the house. So in a broad generality, that's what TCP/IP is doing for us, okay? It's not determining what my web page looks like. It's not determining what the content of my web page is. It's actually not even determining the fact that my web page needs to be in this envelope or how that envelope is structured, but it is determining and giving the rules for if I want to send the message from this computer to a server that's going to host some internet communication, TCP/IP is going to be the rule structure that gets the message to that other endpoint. Okay, is that okay? Understand, please understand, that is a very broad analogy. Okay, very generalization of what TCP/IP is. I mean, I think there might even be in the IT degree, I'm not kidding, an entire class on network protocols. So, okay, next we've got, oh, by the way, TCP/IP, you can see it on the screen, transmission control protocol, internet protocol. I never remember what they are either. I had to write them down. Okay. Next we have HTTP. This one's a little bit easier to remember. It's hypertext transfer protocol. Now, hypertext transfer protocol is going to set up several rules, but back to my analogy, hypertext transfer protocol says that when you write this letter, that's the message which is getting sent, it needs to be in this format, okay? And the content of the letter needs to be found here, and at the top of the letter, you need to have this and this. Oh, shoot, I just thought about this. Who remembers in high school having to write the formal business letter? Did you have to do that in your high school? Did you have the ability to use a computer? I bet you did. That would have made it so much easier. We had to handwrite these things. And you had to like use rulers to make sure that, what a pain, okay? Well, HTTP is kind of documenting at the top. Over on the far left, we need to have this, and then we have to have dear sir or madam, sincerely, having to figure out how to spell sincerely at the bottom. What a nightmare, okay? Right, but then the content of the letter goes here. HTTP is going to define that for us. But it's also going to define a way of communication. And when we communicate with HTTP, which is the primary top layer of protocol rule structure for the web, it's one-way communication, okay? We've got a server where a web page is sitting, web page HTML file, just a text file, sitting over on that server. That server is never going to talk to me directly. The server is never going to say, hey, Charles, here's a web page. Okay. With HTTP, we're always going to have the client, in this case, the user in the web browser, okay, for a web page, form the request and initiate the communication to the server. The server will process our request, determine what to do with our request, and then respond back. So it's always client going to server and server coming back. It's never going to be through HTTP. We're never going to have server initiated communication. Okay? If you want to have server initiated communication, and you can on the web, got to use something other than HTTP. We're just not going to have that. It's going to go one way. Okay. We can get into the gory details of what HTTP is. If you come take one of my senior level electives, we look at the actual format of an HTTP request and an HTTP response, and then we learn that we're going to use a library to abstract that for us. Nice. Let's talk about, did I get in the right page? Yes. Let's talk about HTML next. So HTML is going to be the basis of a given web page. Okay. This is the kind of the foundation that the web page sits on it. And the other two technologies, CSS and JavaScript, are going to then build upon the web page. So HTML stands for Hypertext Markup Language. What is hypertext? In general, we can think of hypertext as just linkable text. If I click on this piece of text, it's going to take me to another resource. That resource could be an image. That resource could be another HTML page. That resource could be a streaming video or streaming song. But the text itself is the link to another resource. The next part is this markup part, the M. There are other MLs, right? There are other markup languages. You don't have to use HTML. There's XML. You can make up your own markup language. But the idea with a markup is we're going to take text, most likely human readable text, and we're going to give that text, we're using this text encoding system, which is the markup language. We're going to give that text context. Okay. So if I write a paragraph, with a markup language, I'm going to state, this is a paragraph. Here is the context. If I write text that has the letters, or the characters 2330 Mountain Creek Street, okay? Now you, as humans, see that as, oh, that's probably a street address, probably. But with a markup language, I'm going to define, this is an address. So how does HTML do that? It's going to do that with the usage of elements. An element itself is going to be a block of content. And we're going to use tags, in this case, our little alligator brackets. These tags are going to define these different elements. There are hundreds of different, maybe not hundreds, 100, maybe 200 different HTML tags that we're able to do. In original HTML, way back when, we might have had a tag for a paragraph. I know that the address tag to make an address element is a relatively new. I think that might be HTML5, maybe HTML4. So we're growing more and more tags. If we have text that needs to be defined in given context, we're going to use this markup language to define it. Now, please remember, it's not up to you, the developer, and it's not up to the HTML to describe how that address is viewed in the browser. It's up to the browser to determine that, and then we'll use CSS to help the browser to determine how we want that address to show up. Okay. With HTML, the entire web page itself is a tree. It's going to be in a tree hierarchy with a root element. So if I look at the outer layer of an HTML page, I'm only going to see one element. And then when I look inside that element, I'll probably see 2, maybe 3 elements. And then when I look inside those other elements, I'll see more and more elements. They all need to be properly nested. When you get into HTML programming, if you're doing HTML programming on a text editor, you're going to always be suffering with making sure your tags are properly nested. If you work with a computer program, I'll call it an IDE, an integrated development environment, which helps you build web pages. It will tell you if your tags are not nested or not. Okay. Here's an example of some HTML. When I talked about the fact that we have one element at the top layer when we look at the web page, that's this HTML element. The starting tag defines what that element is. At the bottom tag with the slash tells us that's the end of this element. What we can't have is, say, this body element underneath this HTML element. It wouldn't be properly nested. Do we go to 130 or 120? 130. Okay, so if you got class at 130, you can get up and go, I guess, but yeah, I want to be respectful of your time. Sorry. Next, we got CSS, and then for those of you leaving, I can kind of speed this up. What's that? Yeah. So CSS, it's the way we're gonna style our documents. We'll see HTML and CSS next week, right? And then we have our friend JavaScript, and we'll see that in 2 weeks. Okay. So I wanted to do some diagramming of kind of messages getting passed back and forth. Maybe, just maybe, I steal some of your time next week to do some diagramming of a web page getting passed back and forth. Okay, so thanks everybody for showing up. Hopefully it wasn't too boring. Hopefully you learned a little something, and hopefully you're okay with me talking in broad generalities as well.
Thank you so much. Please join us next week at 2 of course same time for how this develops. That webpage. So we'll be doing that next week. Thank you again, everybody. For joining.